Every single time you click a link, you're kicking off this incredible journey. A message literally travels across the globe and back, and it all happens in the blink of an eye. But how? How does your simple request for a website get all packaged up, navigate a crazy maze of wires and routers, and somehow find the exact right server out of millions? Well, today we're going to pull back that curtain and look at this amazing, invisible process. So, to make this real, let's follow the journey of a request from, let's call him Johnny. Johnny's in the mood for some good coffee, so he decides to visit a website, networkchuck.coffee. He just types in the address, hits enter, and waits for the magic to happen.
In that split second, right before the page even starts to load, Johnny's computer just explodes into action. It kicks off this super complex chain of events, all to prepare his simple request for what is really an epic journey across the entire internet. We're going to break down exactly what's happening behind the scenes.
Okay, so before Johnny's request can even think about leaving his computer, it has to be packaged up properly. And this isn't like just, dropping a letter in a mailbox. Oh no, it's way more like preparing a highly specialized package that has multiple layers of instructions. And this whole process has a name. It's called encapsulation.
The best way to think about encapsulation is like a set of those digital nesting dolls, The original message, Johnny's request, is the tiny doll in the very middle. And each layer adds a new, bigger shell around it, and each shell has very specific instructions for a different part of the network's journey.
Yeah, let's stick with this mail analogy because it is absolutely perfect for understanding this. Imagine your data is a letter. Encapsulation is literally the process of putting that letter into an envelope, then putting that envelope inside another one, and then that one into another, and so on. Each envelope has a totally different kind of address, meant for a different kind of mail carrier along the way.
So here's how it goes down. First, at the application layer, Johnny's browser creates the basic message. Hey, get me the networkchuck.coffee homepage. That's our letter. Next, the transport layer puts that letter in the first envelope, which has a TCP header. This header specifies the port, which is kind of like a digital doorway. In this case, it's port 443 for secure web traffic. Then, the network layer adds another envelope, the IP header. This one has the final street address, the server's public IP address. And finally, the data link layer adds the very last outermost envelope with a MAC address. This is like scribbling, just give this to the mailman on the corner. It's only for the very next stop.
And here's a cool little detail. As our data gets wrapped up in all these layers, it actually gets a new name at each step. So at the transport layer, once that TCP header gets slapped on, we stop calling it data and we start calling it a segment.
Then, when it moves down to the network layer and gets the IP address added to it, its name changes again. Now it's a packet. And if you've heard any of these terms before, packet is probably the one you recognize, right?
And for its final layer of wrapping, that local MAC address, our message gets its final name for the road, a frame. At this point, it is completely sealed, addressed, and ready to be sent out as an actual electrical signal over a wire or a wireless signal through the air. The packaging is complete.
All right, Johnny's message is all packed up into a frame. Now what? Well, now for the fun part. It's time to actually send this thing out and navigate the huge, sprawling network that sits between his laptop and that coffee website server. The moment that frame leaves Johnny's computer, it immediately hits his local switch. Now, a switch is a pretty simple device. It doesn't care about the final destination in another country. Nope. All it does is open the very outermost envelope, the one with the MAC address, just to see where to send the frame next inside the local network. In this case, that's the router.
And that brings us to a really key difference. A switch, which operates at layer 2, only thinks locally. It's basically asking, where's the very next stop on this little street? And it uses those local MAC addresses to figure it out. But a router's way smarter. It operates at layer 3 and it thinks in global IP addresses. It looks at the final destination city, consults its big map of the internet, and figures out the best highway to send the packet on to get it closer to its goal.
So here's what happens, and this is so important. When the frame gets to the router rips off that outer layer 2 envelope. It's done with it. Then it looks at the layer 3 envelope inside, the IP packet, to see that final destination. After it figures out the best path, it does something absolutely vital. It stuffs that packet into a brand new layer 2 envelope, a whole new frame with a new local address for the next leg of the journey. And this whole process just repeats itself at every single router along the way.
So, after hopping across who knows how many routers, Johnny's message finally arrives at its destination, the web server for networkchuck.coffee. And now, that entire complicated packing process we just went through has to happen in reverse. And logically enough, this unpacking process is called de-encapsulation.
The server gets the frame and starts to methodically open each one of those envelopes to get to the original letter that's hidden deep, deep inside.
So, the server starts unpacking. First, it looks at the outer frame and says, yep, this MAC address is for me, and it just strips that layer away. Then, it opens the next envelope, finds the IP packet and checks, okay, this IP address is also for me. Off comes that layer. It keeps going. Next, it looks at the TCP segment to see that this data is for port 443, which is its secure web service. And finally, with all that network packaging gone, the original data is handed off to the application.
After all those layers, all that routing, and all that unwrapping, the server can finally read Johnny's super simple request. And then what happens? Well, the whole thing starts all over again, but in reverse, as the server wraps up the website's data into a new frame and sends it all the way back to Johnny. Insane, right?
So you might be thinking, why? Why go through all this trouble? Why this super complicated system of layers and envelopes? Well, it turns out this layered model is actually the secret to the internet's incredible power and, more importantly, its ability to scale.
Here's the bottom line, why this all matters. First, standardization. It means a device made by Apple in California can talk perfectly with a server made by Samsung in Korea. Second, modularity. This is huge. It means you can upgrade your home network from a physical cable to Wi-Fi at the physical layer without having to change a single thing about how your web browser works at the application layer. It also makes troubleshooting so much easier because network engineers can isolate a problem to a specific layer. It's just a really elegant way to solve an unbelievably complex problem.
Ultimately, what this system did was create a universal language for digital communication, and that's what allowed the internet to just explode in growth. It really makes you wonder, right? If we can build such a successful, layered system for machines to talk to each other, what other incredibly complex problems could we solve by breaking them down in a similar way?